Okay, we are in part 2 of section 6.5 logarithmic properties, and we are working with this try it where it says expand the natural log of the square root of x minus 1 times 2x plus 1 squared over x squared minus 9. So the first thing that we want to do is we want to simplify anything that can be simplified by factoring, and remember we want to write it as in prime factors, and we also want to convert any radical notation into exponential notation. So that's the first thing that I'm going to do here. All right. So on the top, I'm going to rewrite this square root sign as the exponent 1/2. So I have this x minus 1 times 2x plus 1 squared to the 1/2 on top. All of that over x squared minus 9. So that actually can be factored into x plus 3, x minus 3, because it's difference of squares. Okay, so now taking what we have here, I'm going to make it a little bit smaller so you can see that part there, and then I'll make it bigger as I scroll down. Okay, so now I have division. So division, remember, we can write that as the difference of two natural logs, the difference in the natural log of the numerator and the natural log of the denominator. So let's do that next. So I have the natural log of x minus 1 times 2x plus 1 squared to the 1/2. Oops, look at this. I'm going to run out of space. Minus the natural log of x plus 3, x minus 3. Whew, just enough space there. Okay, so now we can take this 1/2 here. We can move that in front of the ln using the power rule of logs. So this would be 1/2 ln times x minus 1 times 2x plus 1 squared minus natural log of x plus 3, x minus 3. Okay. Make this a little bit bigger now that we've gone down a few steps. Okay, so next, if you look in this first term, you see the natural log of a product. So we can do the product rule for logarithms. So this is 1/2 times, just do it like this, ln times x minus 1 plus ln of 2x plus 1 squared. You could also write it with a 1/2 in front of each one. Okay, but we'll start off like that. Minus the natural log of, we can actually go ahead, this is a product as well, so we can subtract the product, we can write as a sum, the natural log of x plus 3 plus the natural log of x minus 3. Now notice I have that whole thing in parentheses. I'm subtracting all of that. All right, so back to the front. I've got 1/2 times the natural log of x minus 1 plus, look what we're going to do here. We're going to take this 2 and we're going to move it to the front of that. So that becomes 2 natural log of 2x plus 1. 1/2 is still out front. Then what I'm going to do is I'm going to take this negative here. I'm going to distribute to each term there. So I get minus natural log of x plus 3 minus natural log of x minus 3. All right, a little bit more to go. Now I need to take this 1/2 right here, and I need to distribute it to each of the terms here. Right there. So 1/2 times natural log of x minus 1 is just 1/2 times natural log of x minus 1. Now, when I multiply the 1/2 times this 2, the 1/2 and the 2, they cancel and just leave 1. So that'd be 1 natural log, which you don't have to write the 1, of 2x plus 1. And then bring down your minus natural log of x plus 3 minus natural log of x minus 3. So there we have it. Our answer is 1/2 natural log of x minus 1 plus natural log of 2x minus 1 minus natural log of x plus 3 minus natural log of x minus 3. So there we go. There's that answer. All right. So now we're going to talk about condensing log expressions. So given a sum, difference, or product of logarithms with the same base, so that's important, write an equivalent expression as a single logarithm. So apply the power property first. Identify terms that are products of factors and a logarithm, and rewrite each as a logarithm of a power. Next, apply the product property. Rewrite sums of logarithms as the logarithm of a product, and then apply the quotient property last. Rewrite differences of logarithms as a logarithm and a quotient. So we're basically just going backwards. So we're going to do this one right here. So we have condensed a natural log of 3 minus 4 plus 5 minus log 6. So log 3 minus log 4 plus log 5 minus log 6. And remember, when we see the word log, we know the base is 10. So if I'm going to write it as 1, I can take these two and then take these two. So the log 3 minus log 4 is a quotient. We're going backwards, so it was subtraction. So to write it as 1, we write it as a quotient. So it'd be 3 divided by 4 plus log of 5 divided by 6. Okay, so now this is addition. So we can write that as 1 log base 10 of 3/4 times 5 over 6. And we can actually just multiply that out. So log base 10, you can multiply across and get 15 over 20, 15 over 24, which you would reduce to 5/8. The other way you could do it is you could say, you could cross cancel. 3 goes into itself once and 6 twice. So on top, 1 times 5 would be 5, and 4 times 2 on bottom would be 8. So either way, you would get log base 10 of 5 over 8. You could write it in parentheses like that. All right, let's look at another one. Let's condense log base 3 of x squared plus 1/3 log base 3 of x plus 1 minus 2 log base 3 of x plus 1 squared. So the first thing that we should do is get rid of any coefficients in front of any logarithms and write them as powers. So I would write this as log base 3 of x squared plus, I'm going to move this 1/3 here, log base 3 of x plus 1 to the 1/3 minus log base 3 of x plus 1 squared to the, we're going to move this here to the second. So that becomes log base 3 of x squared plus log base 3 of x plus 1 to the 1/3, we can rewrite as the cube root of x plus 1, minus log base 3 of x plus 1 to the 4th, because you're doing a square of a square, which would be to the 4th. You would multiply. Okay, so now we are doing, first I would do this addition here. So writing it as one log, that'd be log base 3 of x squared times the cube root of x plus 1. Okay? And then minus log base 3 of x plus 1 to the 4th. Okay. So next we have subtraction. So we'll write that as quotient. So this would be 1 log base 3 of x squared, x squared times the cube root of x plus 1 over x plus 1 to the 4th, like that. Okay, so this next one is a try it. So why don't you pause the video and attempt this one, and then unpause it and come back and we will go over the answer. Okay, hopefully you had an opportunity to work this. So the first thing that I would do is I would take any coefficients in front of the logs and rewrite them as exponents. So we're going to move those here to make them exponents. So I have log 5, so log base 10 of 5, plus log base 10 of x to the 0.5 power, which I'm going to write as 1/2. Okay, minus log base 10 of 7x minus 1, plus log of x minus 1 to the 3rd power. So I've moved the exponents up. And let's look at the things that I am adding. I'm adding log 5, log x to the 1/2, and log x minus 1 to the 3rd. So I can rewrite that as one logarithm, log of 5 times x to the 1/2 times x minus 1 to the 3rd. Now, we still have this, so I'm going to write that minus log of 7x minus 1. Alright, so next, I'm going to redo this thing here. See, this is subtraction, so that means I'm going to write as the log of a quotient. Okay, so log base 10 of, this is the quotient of the numerator, which is 5, x to the 1/2 times x minus 1 to the 3rd, I believe. Yeah. All of that over 7x minus 1. And that's your answer, although I think I would rewrite this as the x to the 1/2. I would rewrite that as the square root of x. And because I rewrote that as a radical, I might rearrange. I might flip-flop this and this. Rearrange it a little bit. put the radical on the end. So 5 times x minus 1 to the third times the square root of x all over 7x minus 1. Whew. So that was a fun one. There's the answer to that one. All right. Same thing here. We write as a single logarithm. So I would start with the numbers in front and make them exponents. So I've got log base 5 of c to the 6th power plus log base 5 of a to the 1/8 plus log base 5 of b to the 1/8. And since all of this is addition, I can write it as a single logarithm of a product. So log base 5 of c to the 6th times a to the 1/8 times b to the 1/8. All right, so taking it a little bit further. Oops. All right, so now this is log base 5 of c to the 6th. And then 1/8 is the same thing as the 8th root. Write this a little bit smaller. So the 8th root of a times the 8th root of b. And then if you know anything about radicals, you know that we can combine those two radicals because they have the same root number. So c to the 6th times the 8th root of a times b. There we go. Okay, so try this one. And it's a try it, so pause the video, and when you are ready, come back, unpause the video, and we'll go over it. Okay, so first things first, we've got this 4 out front, but it's out front of the whole thing. So I'm going to ignore that for now, and I'm just going to worry about this 3, and I'm going to rewrite it as 4 times log base 10 of x to the 3rd plus log base 10 of x times x plus 5 minus log base 10 of x times 2x plus 3. Alright, so I know that I can write the first two as a product. So that'd be a log base 10 of x to the 3rd times x plus 5 minus log of 2x plus 3. Alright, so now this subtraction, I can write that as a quotient. So 4 times log of, on the top we have x to the 3rd times x plus 5. On the bottom I have 2x plus 3. Alright, and I still have 4 in the front. Okay, so what do we do with that 4? So that's in front of that log. So now I have a log with a 4 in front, so I'm going to take this 4 and I'm going to make it an exponent. So it becomes log base 10 of x to the 3rd times x plus 5 over 2x plus 3 to the 4th power. All right, so you can leave that as your answer. But technically, you can simplify it even further, okay? Or, okay, you could use what you know about exponents. If there's a power outside of a power, you multiply, and now we have a power outside of a product and quotient of power. So technically, we could write it like this. We could say log of x to the, and you could multiply 4 times 3 and get 12, x to the 12th, times x plus 5, so this 4th power applies to it too, divided by 2x plus 3, and that 4 applies to it as well. So just apply the 4 to every factor here. So you could also write the answer that way. So 2 different ways that you could write that answer. All right, and so that brings us to the last little bit here. We have what is known as the change of base formula, and we can use it to evaluate logarithms with any base. And we would want to do this because, if you will recall, well, if you were to use the TI-83 or 84 calculator and use that log button that I showed you in previous videos, you can either, if you choose log, you're doing log base 10. If you choose ln, you're doing the natural log, so log base e. But what if you wanted to do log base 2 or log base 3? Now, Desmos does have a feature where you can do a log of any base, but you can't with the TI calculator. So that's definitely where the change of base comes in handy. So this is the way the change of base works. So if we have log base b of m, we can rewrite that as either log m divided by log b. So log of the big number divided by log of the base, or ln m over ln b. So natural log of the big number divided by the natural log of the base. So if I had, let's say, the natural log of, I'm sorry, not natural log. Let's do log base 2 of 8. So I already know that the answer to this is 3. And the reason I know that is because 2 to the 3rd is 8. All right, so, but what we could do here is we could rewrite this using change of base. I could either do log 3 over log 2, or I can do ln 3 over ln 2. Let me show you how this works in the calculator. I'm going to do a TI. So if I did the log button, 8 divided by log 2. Remember, the answer is 3. There we go. Or you could do ln 8 divided by ln 3. Oops, I did this wrong. I should have did ln 8 divided by ln 2. I was thinking the answer 3, so I put in ln 3, and you get 3 that way as well. So that's change of base. That's the change of base formula. So that is where you rewrite a logarithm with a base other than 10 or e, and you rewrite it as a quotient of the log, either base 10 or base e, of the larger number. And when I say larger, I mean the larger font, and then divided by log base 10 or base e of the base. Okay, so let's look at a couple. So if we have log 0.58, So it says change log base 0.5 of 8 to the quotient of natural logarithms. So they're telling us here they want us to write it with natural logs instead of common logs. So that would be the natural log of 8 divided by the natural log of 0.5. So we just go to the calculator and we would do the natural log of 8 divided by the natural log of 0.5. And we get -3. Let's look at the next one. It says evaluate log base 5 of 100 using change of base formula. So I could either do natural log of 100 divided by natural log of 5. Oops, probably should have put parentheses there. Or I can do log 100 over log 5. Okay. So I'll just show you log 100 divided, make sure you close your parentheses, divided by log 5. You get 2.86. What did they say, round to anything? They didn't say. So I'll just round to 2 decimal places, 2.86. Or I could do ln 100 divided by ln 5. You get the same answer, 2.86. So either way, natural logs, common logs, you can use either one in the change of base formula. I just really quick want to show you if I did the log 100, log base 5 of 100 with Desmos. Now you could do change of base. You could do hit functions, miscellaneous, and hit the log or the ln 100 divided by functions, miscellaneous, log of 5. And you can see you get the 2.86. But you don't have to use the change of base if you have Desmos. So you could do log A, log base A. It's right next to the log button. And then you can see it has a place for you to put your base. So the base would be 5. And then 100 would go here, and you can see you get the same answer. I will say you do need to know change of base regardless of whether you use Desmos or not. So make sure that you review that. Okay. All right. So that is all, I believe, for section 6.5. If you have questions, please let me know.